So in this video, I wanted to solve one of the questions on the worksheet. The question that is about the Fibonacci sequence. If you want to try it on your own, go ahead, try it first, and then look at the solution, your preference. So we have talked about the Fibonacci sequence, and we have, if you go back to our, one of our previous lectures on the for loop, we did this question as a worksheet question also, and we used the for loop where we, remember, exchanged the numbers to get the Fibonacci sequence. So now, we know that that the Fibonacci sequence, right? It's it's a recursive sequence, right? So it's basically the recursion relation for this, as we've talked about earlier, is this, right? So every number depends on the previous two numbers. So one, so you start with the sometimes there is 0 over here also. So let's say you start with 1 and 1, right? Let's say if there's a 0 over here, you can do that also. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 5 is 8, and so on. So that's the Fibonacci sequence, and these are the indices. So this is index 0. So basically starting with 1 instead of 0. Index of 1 is 1, index of 2 is 2, 3 is 3, 4, index of 5 is 4, right? So we're going to write a program where where the user, you ask the user for an index. Let's say the user enters an index 4. The program should print out, or the function should return a value 5. But if the user enters 6, or the function is called with an index 6, the function should return 13. So it basically is the Fibonacci function. So let's do this. So what we're gonna do is we're gonna define a function. You can call it Fibonacci fib, and then it's a function of n, right? So that's the index that the user enters. Now again, so now you need a base case, right? So base case, let's write base case. The base case is that if n is equal to 0, so if the index is 0 or the index is 1, we should just return these two values, right? So if n is equal to 0 or n is equal to 1, return 1. Okay, so that's the base case. The recursive part is where so remember, now the recursive part should involve calling the function again, right? So that's the whole idea of recursion, right? So then return, and it should else return, so fib of n minus 1 plus fib of n minus 2. It's that recursive equation that I wrote in the beginning, right? So that's it. This is it. So you can see that with recursion, it is easier to implement the Fibonacci sequence. So the problems that have a recursive nature, they are basically easier to implement. Some problems become complicated with recursion. Some problems are easier, especially those with a recursive behavior. So now our function is ready, right? Now we can, in the worksheet, you've been asked to, you can do that part for the worksheet. You've been asked to, ask the user for an integer, and then you print out the number at that index. So let's say if I want to print out the fifth, right, the number at the fifth index, so then I can just then call the function with the number 5, right? And so we'll get 8, right? If you want 6, it's going to be 13. So you can do anything now. So you can go to higher numbers also. Okay, so this was the Fibonacci function with recursion. I would suggest you go back to that other worksheet also and compare. That's going to help you see what's the difference. But again, this is easier with with recursion. Okay, So let me know if you have any questions on the discussion.